Hello, how we doing? Welcome to the shop, to the workbench. This is gonna be my first real actual stream. Nothing is scripted. I don't have a clue what I'm doing. So we'll figure it out together. So tonight we're gonna be working on an isolation line conditioner transformer. This channel is gonna be primarily about electronics repairs, more on vintage audio, old school type amplifiers, guitar amps, space amps, PAs, that type of stuff. So let's get started. All right. I don't know how this is going to come out on camera, so we'll just do the best we can with what I've got for now. So, what we've got here, this guy is a line conditioner isolation transformer. You've got your plug here, and that'll go plugged into the line. And you got some outlets back here where you can plug in whatever you're working on, that type of stuff. If you don't know what the heck an isolation transformer is, basically, when you're working on electronics, anything with power, anything plugged into the wall, anything with high voltage, you really do not want to be working on that, especially hot, when you don't have any kind of separation between the outlet and the wall. Because if you come across the voltage, you make a mistake, whatever, you've had a little bit too much to drink, you're not paying attention to what you're doing. And by the way, I do not recommend drinking at all while working on any type of equipment. We'll just do a little PSA now. Electricity is dangerous. You can get hurt, you can get burnt, you can get killed. DED would not be good times. Don't want to be out tinkering in your shop on something and wake up dead. That would be bad. So if you are working on anything, you plan to do any kind of repairs, anything like that, you're watching YouTube or whatever, and you're thinking, hey, I can do that. Well, maybe you can, but you need to be safe about it. So just keep that in mind. If you're doing anything on your own, you're doing so at your own risk, and be safe. All right, so back to what we've got going on here. This, you would think, okay, this is an isolation transformer. That's what they classify it is. If you're looking online, you're looking to buy one, you type in isolation transformer, chances are something very similar to this or this exact one will come up. There's quite a few different ones out there. You can buy these on eBay used for $100 or less. That type of thing. So this guy here, though, back to the point, you're thinking this is an isolation transformer. I bought one. I'm going to plug in. I'm going to use it. I'm going to let you know right now that this is not as safe as you think it would be. You're thinking, I've got this plugged into the wall right here. I'm working on my equipment that's plugged in back here. It's an isolation transformer. I'm safe. I'm going to tell you, this guy right here, along with most of the other ones that are on the market, have what I would consider a flaw if you are going to use it specifically as an isolation transformer. So let me get to the point, and we'll just test it, and I'll show you what I'm talking about. You may be thinking, what the heck are you talking about? Okay. Let's get this guy in here. Multimeter. So we're going to put this on ohms. And guys, I apologize for the camera setup I have right now. It's what I have at the moment, so it's what I'm using. Hopefully in the future I will be getting some better equipment, but we're using what I've got for now. So we've got our multimeter set on ohms. What that's going to do is it's going to read resistance. If you're not sure how to use a multimeter or what any of these functions mean, I would suggest just, if you're interested in this type of stuff, jump on YouTube, type in multimeter, how to use, blah, blah, blah. There's tons and tons of helpful videos, good information out there. So I'm not going to cover that, but if, maybe later in a different video or something, we'll go over basics of how to use a multimeter. But for now, I'm going to assume that you know how to use one, and if you don't, feel free to jump on YouTube and check it out. Alright, so we're on ohms right now, so basically I'm reading resistance between here and here. So if I touch these, we get an audible tone. We see that from OL, which is open line or open or no continuity, when I touch this together, we are reading through, if it will work, we're reading through the wires coming from here back to here. You will see this jump up and then go back down to 0. If there's a few numbers on there, it's just reading the resistance through the actual wires themselves. Like I've got 0.3, so 0.3 of an ohm, that's what's reading through the wires. No big deal. So back to this guy. I'm going to turn this up so hopefully you can see what I'm talking about. Alright. So, on your AC line in your house, you have your ground. You're going to have a neutral and a hot, or a line. When you have an isolation transformer and you're trying, what the goal is of an isolation transformer is to separate yourself from the line voltage, or from the power coming out of the wall, and go through a transformer. That way there's no physical wire connections from the device you're working on to the power supply. You're still going to have power to the unit because of the transformer. I'm not going to cover that in this video. Like I said, there's tons of videos on how transformers and stuff like that work out there. So this guy here, basically, if I put this, can you see this meter here? I'm just going to stick this probe in here on the ground. Okay, so that's ground. So if I go on the plug side here, right here on my third prong, the ground prong, and I touch that, we have continuity. So we have a path from the ground to the ground on the ground prong on the other side of the transformer. That's good. You want your equipment to be grounded. The issue with this is if I come over here to my neutral side and I come in here and I put that probe in there, hope you can see that, and I probe over here to my ground, oh crap, I've got continuity from my neutral to my ground. That is a big issue. We do not want that at all. So I'm going to show you how to fix that on this guy. We're going to take this guy apart because we don't want our ground reference to our neutral wire. That's essentially not isolating our line. That can cause problems. That can cause breakers to trip. Basically, if I'm working on something and it goes short circuit, or I screw up and I'll cause a short circuit, we've got our neutral right to ground. Now, that's going to cause some issues. I wish I was a little bit better at explaining exactly what that would do, but essentially, in your home electrical system, you've got your power wires coming in off the pole. They go into your meter box, which reads how much electricity you're using. That way they can charge you for what you're using. Then it goes into a main breaker panel. At that breaker panel, you're going to have your neutral tied to your grounds. That's how it's supposed to be at the service panel, and only at the service panel. If you were going to, like here at my shop, I don't have another camera that I could show you, but out here in my shop, it's not attached to my house. I have my main power wires coming into my house, go through my meter and into my electrical box. And my neutral wire is, all my neutrals in the house are grounded to the ground bar, to the ground wire, and coming out and going into a ground rod, and then going back to the transformer that's on the pole from your electric wires coming from the house. Then I've got a sub panel in my garage. So if you add a sub panel or another breaker box or something anywhere else in the house or in a garage or a shop or anywhere else, you do not tie your ground to your neutral in that sub panel. That causes problems. What that's going to essentially do is you're going to get current flowing back on your ground wire, and that can cause main issues. So what you do is you run 3 separate wires back to that panel, or if you have 220 running out there, then you would have your 210 volt legs, a neutral and a ground, running all the way back from your sub panel back to your main breaker panel in your house. What this little guy here is doing is it is tying my ground, or the ground, to the neutral right here in this unit, and that's not good. So I'm going to show you, instead of babbling on and on and on, we're going to get this guy apart here. And I'll show you what's going on. And guys, if you're interested in this type of stuff, if you'd like to drop a follow, man, that'd be great. I plan on making a lot more videos in the future. I've got a lot of projects going on. So if you're into this type of stuff, man, enjoy having you here. Hopefully you can learn something from me. I don't claim to be a professional at all, because I am not. I just like to tinker and learn things and have fun. So back to this guy here. Okay, let's cover this real quick. I'm hoping you can see this. Let's do this and set this guy up so maybe you can see a little bit better. There we go. Alright, so this big guy right here, what the heck is that? Well, that is the actual transformer. And it is a 1-to-1 ratio, meaning the turns on the primary side of this are the same amount or the same number of turns on the secondary. So what that does is there is not a voltage decrease, there is not a voltage increase. What I put into this transformer is going to put the same exact amount of voltage out on the secondary side, thus creating an isolation. Because you have, wish I had a piece of paper here. Let's grab a piece of paper. Why not? I'm not very prepared tonight, but we'll just run with it and see if we can't make this work. Let's get this guy out of the way for just a minute. I'm sorry if that was loud. Alright, let's see here. I said I wasn't going to explain transformers, but I'm going to. I can't help it. This is a crash course on how transformers work. Okay, so you're going to have your line, and we'll just call one L and one N. So neutral and line. And you cannot see that at all. I'll hold it up when we get done here. 120 volts, more or less. It may be 115, 110, 115. It may be up to 130, just depending on your neighborhood, what city you live in, blah, 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 how much stuff you're using in your house. But for here, we're just going to say 120 volts. And you're going to come through and you're going to make a winding. And this is going to be, connect that there and there. So let me get this up here and see if you can see this here. Okay. So 120 volts, your line and your neutral. That was going to be your 2 wires coming out of your plug. There's going to be a third one, that's going to be your ground. Okay. So you're going to have a winding right here, which is just a bunch of coils of wire, a bunch of turns of wire. If you took a wire and you started wrapping it in a coil, that's what this is right here. You're going to have an iron core. This is a crappy drawing and I apologize, but hey, it is what it is. This is your iron core right here. So essentially you would have, just say, a piece of metal, you know, a block of metal, and you're going to have a bunch of wires wrapped around it. That's what this core is right here. Like I said, there's great videos on YouTube just if you want to learn more about transformers and how they work. Lots of good information out there. Okay, let's draw this side of it. Okay. All right. So this is going to be your primary, and this is going to be your secondary. You got a coil of wire here, iron core, coil of wire here. So as you can see, you're creating inductance when power runs through this coil right here. It's creating inductance, and that's going to energize this coil right here. And if your wire turns are 1 to 1, exactly the same, so just say you had 100 turns of wire right here and 100 turns of wire right here. The voltage you put in on the primary side, let's just say it's 120 volts, that's what's going to come out on the secondary side. 120 volts. Simple enough. If you want to change how much voltage comes out of this, you either add more windings, more turns of wire to it, or you take less away. So say your cell phone charger. You plug your cell phone charger into the outlet, well, that's 120 volts. Your cell phone doesn't run on 120 volts, it runs on like 5. So how the heck is that working when you plug that in there? Well, it has a transformer in it, and what it's basically doing is you got your primary winding here, say 100 turns, and your secondary winding over here is a different number of turns. So what's coming out on the secondary side is not the 120 volts that's coming in. It could be 5 volts. So that's basically how a transformer works. And there's a physical separation. Your line wires are not connected physically to each other in here. That's what we want. We want a physical separation. And, you know, there's lots of reasons for that, but the main reason is safety. If I've got 120 volts on this side and my breaker in my house is a 15 or just say a 20, pretty much most of them are usually 20 amp breakers. If I get across this, if I'm working on something and I end up shorting something out or touching something in here, that's 120 volts at 20 amps. That's going to leave a mark. That's going to hurt. That's either going to injure myself or, you know, it could possibly kill you, which would be a bad day too. So I'm not saying that with an isolation transformer that I'm not going to get shocked. That's not the case at all. Yes, even with an isolation transformer, I can get electrocuted. I can get shocked. But the amperage on that line is going to be less. I'm not going to get the full amount of amperage coming through there. It's a safety buffer, a factor. So with this transformer right here, this one we're working on, they have, let's get back to this real quick. Sorry, I'm jumping ahead. So your transformer is your iron block, okay? And it's mounted in a metal box. And that metal box just put it right here. Has a little nut on there, and this ground wire coming in from the plug goes right here. And the transformer has what they call a center tap, okay? That's a center reference point for the voltage. That also goes to ground, and that's fine, that's perfectly fine. Now over here, our ground wire coming out on the secondary side, this guy comes over here and is tied to that same ground point, and that's perfectly acceptable. That's perfectly fine as well. The issue is, and I'll show it to you, they have the neutral also right here on the back of the outlets. That's also runs over and ties to ground. That's not good, so that's what we're going to fix. So let me put this away, and we'll get right to it. Oh, sorry about that. Alright, watch your ears. I'm trying not to drag this across the table. Okay. So, right here, I don't know if you can see this. Let me see if I can move this up and I can show it to you. This guy is not very light. Right in here, you see that right there? That's our ground point. And if you'll look, let me turn this like this. Here's our power cord right here, runs into the unit, comes right through here. The neutral side goes into number 2 terminal, which really doesn't matter on this, but you're going to have 2 terminals on the primary. It goes to a terminal. This is great because we've got a little inrush capacitor right here, a little XY capacitor. That's good for safety, noise filtering, stuff like that, blah, blah, blah. Also, here we go. This black wire right here comes right from the power cord, goes through our switch right here. And what I like about this unit here is this is a switch, yes, on and off, but it also serves as a breaker. And I can show you maybe if the lighting didn't suck. Okay, let's see if I can get up here to it. This will show you the trip amps. I don't know if you can see that, trip amps. And it's 6.25. So this guy right here is a breaker also. So if I pull more than 6.2 amps on this transformer, it's going to trip this guy. So that's an extra added protection device there, which is good. Hey Dur, what's up, buddy? Yes, on and off. Yes, you got it? Am I blabbering? Let me know if I'm blabbering. So back to the primary winding, and this son of a gun is heavy. Back to the primary winding. Here is your center tap, this green wire here that I was talking about earlier. Comes down here. Well, here's the problem with this guy. See if I can get in here so you can show it. And you can't. There we go. There we go. Okay, see this white wire right in here? This guy right here. That's the neutral side that's coming out on our outlet. This right here, a little strap of metal. And that son of a gun goes from right there from the neutral right over here to the ground. So maybe you can see that. Let's get this guy up here. There you go. That's no wieners, so we don't want that at all. And there's 2 outlets on here, and there's a strap on both of them. So what we're going to do is we're going to take it apart. We'll see how this goes live on camera. You playing any Tarkov tonight, Dur? We're going to pull this guy apart. Hopefully this isn't too boring. Guess you can grab a cold snack or your drink of choice and sit back and relax and enjoy the background music for a little bit, and we'll get this guy apart. Alright. Doing stuff and things. I'm going to set this down flat on the table so I don't knock it off and make a loud noise and scream and cuss and hurt my finger and all that good crap. Although that might be entertaining to y'all, it would not be so much for me. See if this is going to come out easy or if it's going to be a pain. Never know. There we go. There we go. You see that little clip? That's what we don't want. Alright, I'm going to leave that ground off for just a minute so I can get to this one a little bit easier. Cool thing about this guy is, if I can flip this over, you've got some, this is a line filtering. So you've got some capacitors right here, little resistor to balance. And that's basically just going to put some capacitance across the line, which is going to filter it a little bit. So if you have spikes on your line, no power surges, dips, whatever, you got, turn something on and it pulls a lot of power and it drops down. That type of surging on your line is not very good for electronics, period. That will cause capacitors and other things, sensitive equipment, stuff like that, to go bad over time. And you know, one day you wake up and try to turn your TV on and it won't turn on, and you're thinking, what the heck's going on? And got a little spike or something and it didn't like that. So but this is good for filtering out those spikes in the line, in your AC line. How's it sounding, Dur? Is everything sounding all right? Sounds good. Cool. See if I can get this guy to go back together. Oh, sorry about that. Dragging my mic across this. Alright, so we've got both of our little metal clips that tied the neutral to the ground. Those are removed. Just get them out of there. Don't need those guys. Alright, we're just going to look it over because it's always a good idea to look stuff over and make sure you didn't knock any wires loose, didn't screw anything up. Like I just did there because I pinched that wire when I put this guy back in. Get out of there. Alright. So now that that's removed, see if I can get this meter in here. Now, if I did this right, when I check between neutral and ground, we should not have any continuity, so that meter shouldn't do anything. It should stay exactly like it is. It looks good. Let's check from case ground to the ground, and we have continuity. If I can hold that in there. And then also, check from, we got to get better camera set up. I'm going on the ground prong right here on the main power cord. We're going to check case ground. We're good there. Check all the ground ports on the plug. Okay, we're good. So unit is grounded, but we have eliminated the neutral tied to ground. So now this is an actual isolation transformer that will work the way an isolation transformer is intended to work. So we'll just get that cord out of the way. We'll slap this cover back on, put it back together, and we'll plug it in and see if it works, because I have not plugged this in. I got this thing. It's sat around for a while and I hadn't done anything with it until tonight. So I haven't even plugged it in. I don't even know if it actually does work. It may blow up. That'd be exciting. Okay. Give me just a second. Alright, I'm back. Okay, let's yeah, why not? Let's talk about another device, since this is going to be a channel about working on audio equipment, modern and vintage, but more than not vintage. And I'll go over more stuff on the do's and don'ts on vintage equipment. I'll get more in detailed on that when we start working on some more stuff like that. But let's get this guy out of the way real quick. Since we're talking about safety equipment and stuff, you know, for a workbench, I'm going to bring out this guy and talk about it for just a minute. Alright, and you're thinking, oh, okay, a box with a light bulb in it, that's cool. What the hell does that do? Okay. I'm going to tell you what this guy does. This is a dim bulb tester. And what it does is it puts a light bulb across the line, across your live wire, In the event that you plug something in and it is shorted, instead of blowing up, catching on fire, or tripping your breaker, all it will do is turn this light bulb on. So, and I can demonstrate that if I can find a piece of wire. Stick a wire in an electrical outlet. Like I said, if you're doing this type of stuff, you are doing this at your own risk. Please do the proper research and have a little bit of knowledge about what you're doing so you don't get hurt or hurt someone else or any bad stuff like that. So, I don't know if you can see that. Yeah, you can see that. Okay. So if it's off, that light's off here. If I turn the switch on, that just simply means there is power on this device, and this outlet right here is hot. So if I see if I can get everything in shot here, we're going to turn our multimeter to AC voltage. Can you see that? Yes. Okay. So if I probe this outlet here, as you can see, there is 121, and there's a decimal point right there, you can't see it, 121.4.5 volts. So 120 volts on your line. Turn the switch off, kills power to my outlet. And you can't see, no, that looks funny, but right here there is a decimal point. The decimal point moved over. So that's just simply saying there's 3.6 volts coming out of that outlet when it's hot. That's going to be transients and, you know, inductance through the switch, that type of stuff. Essentially no voltage on there. Turn it back on. There's my 120 volts. So what I'm going to do is I'm going to turn it off. I'm going to pull out these. Let's see. Let's have some fun here. See if I can find some wire. I was not planning on showing anybody this tonight, so I'm not prepared. But we can find some wire here somewhere, maybe. Surely I got some wire laying around here somewhere. Okay, I'll be right back. I'm going to grab some wire real quick. Just hang on a few seconds. Alright, I'm back. I've got just an old lamp socket. So we're going to take a piece of wire off of that. And I'll show you what this guy does. Put that guy out of the way. Okay. So I've got here just a piece of wire. And what I'm going to do, move this out of the way. I'm going to simulate what this does and why this is a good device to have on your workbench, especially if you're working on audio equipment or vintage audio equipment. So it is off right now. I'm going to simulate a short circuit. Once again, do not do this in your house. Don't think, oh, I saw Germ Crow do it. He just stuck a piece of wire in there and that light bulb lit up. Don't do this at your house. You stick a piece of wire in your outlet, in your wall of your house, you're going to have a bad time. This is a safety device that is purposely built that if there is a short on this line, all it will do is make this light bulb light up. So we're going to take this piece of wire, we're going to shove it in there like that, Okay, cool. Is it gonna blow up? No. Hey, it's pretty bright. Can't see a damn thing, but there you go. There you go. See, look, short across the line. Turn the power on. Get my wire in there again. Yeah, strobing out. There you go. Just makes the light come on. That's all it does. And what this is for, like say, you know, there's a transformer or something, or hey, you know, look at this guy right here. I don't know if this thing's even any good. I don't know who had it before me, what it was used for. I don't know anything about this other than what it is supposed to be used for and the modifications we just did to it to make it an isolation transformer. So this may have a shorted transformer. It may be bad. I don't want to just plug this in and trip my breaker or blow something up. So this is a perfect opportunity to try out our little box here. So we'll plug it in. Switch here is off. Okay, we got power now. We'll turn it on. See what happens. All right. I know this isn't shorted because our light bulb didn't light up, so we're good. So now, if I can get this to stay on without turning the switch off and get all this in the shot here. We're going to check and see if I've got 120 coming out. We're going to see if the secondary winding on this transformer is good. And it is. We've got 123 coming out. We'll check the other outlet. 123. All right, so this guy's good. We performed our mod. We isolated the neutral from the ground, so it will be 100% isolated from the line. And we'll be able to use it as it's intended to be used. Alright, let me get some of this stuff out of the way here. And we'll get this little guy put back up. Preferably without dropping it and breaking the light bulb, because that would be bad. One thing I did not mention about that dim bulb tester is that's a current limiting, if I can speak, a current limiting device as well. When you put a light bulb across the line, then you've got resistance going through that bulb. So you can change the wattage on that bulb, and that's gonna limit the current going to whatever device is plugged into it based upon what wattage is in that bulb. So if I put a 300 watt light bulb in there, it changes the resistance, it changes the current. If I put a 40 watt light bulb in there, it's going to change, you know, again, the amount of current that whatever's plugged into it is going to be able to receive. So I hope y'all guys liked this video. If you enjoy it, hang around. We're going to be doing some more stuff. Let me grab hopefully what our next project's gonna be. I'll be right back. Alright, what we have is a custom guitar amplifier from the 70s. Let me put my microphone down, you might be able to hear me a little better. This is a custom guitar amplifier from the 70s. It's really, really neat. It's in a rolling cabinet that's got padded green vinyl on it. This thing is in very, very decent shape for being in the 70s. And this belongs to a guy who actually plays around in some bands here locally. And I can already see we're definitely going to have to get better cameras and a different setup. But here we go. Turn it up. I'll just pan across it here so you can see. This is just the brain. This is the amplifier itself out of the cabinet. So this hopefully will be our next project. I know this guy's dying to get this back, and I've had it for about 4 months now and haven't done anything other than plug a guitar into it and jam out and verify the issues it's having and pull the brain out of the cabinet. So we'll this is solid state. We'll go ahead and pop this cover off real quick because I've had this cover off. I've done a little bit. I say I haven't done anything to this, but that's a lie. I've done a little bit of troubleshooting on this guy, and all signs are pointing to a bad or faulty transistor. Which, well, let me tell you what the symptoms are. The symptoms, with nothing plugged into this, no instruments plugged into this. Hey, what's up, Booster? You're selling me your tube amp for $100? Send me a picture of it, man. I may be interested. Thanks for stopping by. So, with nothing plugged into this guy right here, it hums, it hisses, and the longer it's plugged in, the hotter it gets, the longer it's sitting there idling, warming up, the louder the hissing gets. You plug in an instrument to it, it sounds great. This thing will blow your eardrums out. It sounds phenomenal. But there's a hissing in the background, like I said. And that's not good when you got an amp sitting there, you know, when you're in between songs on a set or something. This thing's just sitting there squealing and hissing and causing all kinds of crazy chaos. So basically, let's get this cover off here. And geez, my camera sucks. Okay, yeah, we're definitely going to work on getting better cameras. Let me raise this guy up a little bit so you can we'll do a flyover. Here you go. You can kind of get a look at what's inside a guitar amplifier if you've never taken one apart. And like I said, this is transistor based. We have our transistors right here. This is the top side of them. If I flip it over, there you go. These are our TO3 packages right here. So TO3 style transistors, very, very common in early 70s and 80s amplifiers, even hi-fi amplifiers. That's TO3s. That's what they used. So one of these guys, either in the output, it could be an output transistor, or it could be in our preamp. This right here, I know you can't really see anything. Let me see if I can get this up a little bit higher for you, so you can kind of see what the heck I'm talking about. Is that any better at all? Probably not. Oh well. Just follow along the best you can with me. So right in here, this is our preamp section of the amplifier. Right here we've got all of our sound staging, our bass, treble, mid-range, volume, reverb over here in this section, tremolo. This has a vibrato. It's got all kinds of goodies on this guy here, but all that's right in here. And then that comes over to our actual preamplifier, which is in here. So I don't know if you can see right here, I'm tapping on, probably not. Let me see if I can get this up a little bit higher for you without dropping it on myself. This guy right here, and there's another one. These are transistors, and there's also some more transistors in here. So these 70s style transistors, they just, they get old. They're old. They're tired. They start breaking down internally and causing issues. Values change, capacitance inside the transformer inside. Hang on just a second here. Okay. Values inside the transistor changes over time as the materials they were made with break down, causes issues. We got, looks like a germanium transistor right in here. Here's some more transistors. So yeah, I mean, this stuff gets old and it starts breaking down and you start having problems, and noise issues with them. The issue with this guy right here, I've done a little bit of research on the part numbers of these transistors, and they are getting very, very hard to find. When you do find them, you're talking, they want $100, $200 for one stinking transistor, and there's what, 2, 4, there's 6 on 7, 8 on the preamp board, and then your TO3s style over here, your main driver transistors, power transistors, so it gets expensive quick. I am not going to buy cheap stuff. I do not repair other people's equipment. If this was mine, yeah, if I just used it to practice on here and there, why not? I might buy a cheap knockoff, from, I'm not going to say it, but from across the pond made transistor, which is not the same quality, nearly the same quality, even close to the originals that are in this. But if it was my personal amp that I use, maybe for an hour every month or so, just to screw around out here in the shop and jam out for a couple hours, yeah, I might throw a $5 knockoff, fake copy transistor in there just to get the thing working. Another issue with that, though, is it's not going to last as long as this one has. But the main issue is this is not mine. This is a customer's. If I'm going to fix it, I'm going to fix it right. If I can't get the parts to fix it, then we're not going to fix it. It's that simple. I'm not going to Mickey Mouse it together and charge the guy for it, and it work for, a week or 2 or 3 weeks, and then he's right in the middle of playing a set and it blows up on him. That's not how I roll. So yeah, parts are getting very, very hard to find for this older equipment. But to be honest with you, that is actually, for me, some of the fun in working on this older stuff is the search, the hunt to find it. So, I mean, like I said, there's a few parts floating around out there in La La Land, but, it may come down to, I'd ask the guy if he wants it fixed. Well, it's going to be, a couple $1,000s in parts to fix this thing and fix it correctly. And if he wants to spend the money on it, great, cool. We'll do it for him. But to be fair, in all honesty, if you don't have any sentimental value or anything to this amplifier, I can jump on eBay and buy a good, decent amplifier identical to this one sitting here for $800. So, it's up to the customer what they want to do, but this is just a hobby. We have fun at it. If we can fix it, we'll fix it, and if we can't, then we'll move on to something else. But all right, so that one will be coming up. I'll hopefully here pretty quick. I'm hoping here within the next at least week or two, I can get some better cameras. We can get a little bit better setup. We can start getting some of this stuff I've got piled back here on the bench and back up working. So guys, I appreciate it. I'm gonna throw this up here real quick. This is the background music from YouTube. This is the guy's channel. He just asked to have his link either posted or displayed in any videos we may be using, so blah blah blah. If you enjoyed the background music, go check him out. On that note, I appreciate y'all watching, and we're gonna call this one done. Thanks, chat. Love y'all guys. Appreciate y'all stopping by. And we will holler at y'all next time. Until then, take care.